Okay, let's see what we got over here. So it looks like we have another integral equation from this left-hand side. This right-hand side is a decimal, and it seems like it puts a spanner in the wrench. No, sorry, spanner in the works. Now, this 0.01 over here, we can simplify this, or not simplify, but really just rewrite it as a fraction form. We can say that this is actually 1 on 1,000. And so if you want to solve an integral equation, what we've done so far is really just equated both sides as well, equate the indices on both sides as long as they have the same base. So we'll recognize that this base 10 is quite easy to work with because we're going to have 100 here, and we also have 1,000 on the right hand side. So I'm going to leave this 10 to the power of 3x minus 1. Now at the bottom, this is really 10 squared to the power of x. And this is equal to 1 on 1,000. Okay. Let's just work with this a little bit more before we do any rearrangements. So over here, this 10 squared to the power of x is really 10 to the power of negative 2x. So what we did here was the 2 and x would multiply with each other, and then you can flip it to the top as a negative index. Okay, and this 1 on 1,000 is really just 10 to the power of negative 3, since we know that 1,000 is really just 1,000 is 10 to the power of 3, and if it's positive on the bottom, that means when you flip it to the top, it's going to be its negative version. Okay, now to keep going over here, we do need the left hand side to be a little bit more collected. So I'm just going to say it's 10 to the power of 3x minus 1 plus this negative 2x, so minus 2x, equal to 10 to the power of negative 3. Okay, let's tidy it up a bit more. Alright, and from here you can equate both indices since the bases are the same. So x minus 1 is equal to negative 3, and it's pretty clear from here what x is. It's just going to be negative 3 plus 1, and that is negative 2. Just don't make the mistake of saying that, negative 3 plus 1 is negative 4. That's about it.